So we're going to take a look at this system of equations problem. We're going to solve it two different ways. One graphing and one symbolically or algebraically. So if Manny gives Neil $6, then Neil and Manny will have the same amount of money. We need to turn this into an equation. We know that Manny is giving Neil money, which means he is going to lose $6. Whereas Neil is gaining that $6, so he is going to be added to $6. And we know that they will have the same amount of money, which means if Manny loses $6 and Neil gains $6, they will have an equal amount of money. The next statement says if Neil gives, so now Neil is losing 6 and Manny is gaining 6, then Manny will have 3 times as much money as Neil, which means Neil minus the $6 is going to equal Manny plus the $6 if we multiply Neil's value by 3. So now we have two equations. Let's solve them. I'm actually going to solve them 3 different ways, because why do 2 when you can do 3? First, let's do the simplest, but probably the most work-intensive, graphing. So we have the statement m minus 6 is equal to n plus 6, and I really want to get this into an equation that's easy to work with. So I'm going to get this into, I don't know, standard form. So I'm going to add 6 to both sides and subtract n. And I will get n minus n is equal to 12. For my other equation, I'm going to do, let's go ahead and just, no, let's keep the n. I'm just going to rewrite it. And so I'm going to divide both sides by 3. And I have to divide everything by 3. So since I'm multiplying n and negative 6 by 3, I can just go ahead and say I'm dividing the 3 here. 3 divided by 3 is 1, so I get n minus 6 is equal to, m divided by 3 is the same as saying 1/3 times m plus 2. Well, let's get the n by itself, plus 6, and so I get n is equal to 1/3 m plus 8. Now, I have a standard form expression and a slope-intercept form expression. I can go about this several different ways. I could use my slope and y-intercept to use my graph. No, it's not going. Or I could, well, n is equal to 1/3 m plus 8. I could plug that in here. Or, if I were so inclined, I could also get this equation into standard form. So there are lots of ways I can do this. Let's go ahead and, my graph is down here, and it won't let me pull it up outside the screen, which is a little bit irritating. Here we go. So let's go ahead and do this graph. Let's go about it that way first. So let's call this, I'm going to scoot this graph up a little bit more. So I'm going to show graphing using 2 different means for each of the 2 equations. I'm going to turn this blue, so we have a blue and a green. So let's start with the blue. So we know that we have Manny's money, and I'm going to count by 2. So 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. For Neil's money, we have 0, 2, 4, 6, 8, 10, 12, 14, 16, 20, 24. I'm just going to stop there. All right, so since the scale is the same for my x and y axis, I can just use this y-intercept and the slope. So my y-intercept is 8, and my slope is 1/3, so it's up 1 over 3. 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 And I know I'm a little bit off screen, sorry about that. And then I need to connect the dots. And I'm going to use a straight line tool because I can. And hopefully, one of my points is off, I see. Hopefully they all line up, and obviously I didn't go over 3, so here's the 3 up. Sorry about any confusion I may have caused anybody. Okay. So now, I'm going to graph this one using a table. So if m and n, so if m is 0, n would have to be -12. Well, that's going to be way down here. That's not so good. I only really want to have positive variable or positive values here because I know they both have to have a positive amount of money. So let's say m, so m would have to be more than 12. So let's say m is 12. If Manny has $12, that means Neil would have 0 based on this equation. Let's go with 16. If Manny has 16, Neil would have 4. Let's go even bigger. Let's go 30. So if Manny has 30, then Neil would have to have 18. So I'm going to plot these 3 points. So 12, 0, it's right here, 12 over 0 up. 16, 4, it's right here. 30, 18, it's right here. Oh, that's convenient. And let's go ahead and take a straight line tool. And I'm going to be using green. I'm going to connect. So my, there we go. My board is not calibrated too well. And so my solution is right here. So Manny has $30 and Neil has $18. 30 plus 18 is 48. Will they have enough money to buy a $50 video game? No. No, they will not. So I'm going to move my graph so I can reread the problem statement. And it's asking, can they buy a $50 video game? The answer is no. I showed and explained how. Great. But I did not define the variables. This, as silly as it may sound, is critical. We have to say m is equal to Manny's money and n is equal to Neil's money. That is a necessary part, or you will actually lose 1 whole point if you do not do that. Now, there are other ways to do this problem. Let's go back to the equations. I know that n, I really want that to be a pen, I know that n is equal to 1/3 m plus 8. Well, instead of this n, what can I write? 1/3 m plus 8. So I'm going to rewrite this equation, but substituting in this value for n. So I know m minus 1/3 m plus 8 has to equal 12. Okay. Well, if I have m minus 1/3 m, then I have 2/3 m remaining plus negative 8, because the 8 is in the parentheses, and the whole thing is negative, is equal to 12. So add 8 to both sides. So I get 2/3 m is equal to 20. So what's the opposite of multiplying by 2/3? Multiplying by 3/2, multiplying by the reciprocal. So that gives me m on this side because they cancel out. So that's 10, that's 1, 10 times 3 is 30. So now Manny has $30. 30 minus something is 12, 30 minus 18 is 12. So then n is equal to 18. And we have to be careful to make sure we define this. This is called the substitution method because I substituted an expression for a variable. Last one, this is my personal favorite way, and this is how I would go about solving this problem. This is called the elimination method. And the elimination method requires standard form. So I know that I have m minus n is equal to 12. And I also have, over here, I need this in standard form. So I'm going to go back to the 3n, I'm going to distribute this, minus 18 is equal to m plus 6. So instead of dividing everything by 3, I'm just going to distribute the 3. And then I'm going to get the m by itself. I'm going to get the m and the n together to create standard form. So I'm going to subtract 3n from both sides and subtract 6 from both sides. So I get, hello Lorenzo.
Hello.
So negative 18 minus 6 is? You gotta love being put on the spot.
Okay, negative
18 minus 6 is negative?
So it'd be negative 24.
Negative 24 is equal to m minus 3n. Okay, so I'm going to write this over here. M minus 3n is equal to negative 24. And for the elimination method to work, I need to eliminate one of the variables. To eliminate variables, I need to have opposites. What's the opposite of m? Negative m, but this isn't negative. So what I'm going to actually do is I'm just going to subtract these equations. M minus m is 0. Negative n minus negative 3n is going to be, well, subtracting a negative is the same as adding a positive. So negative 1 plus 3n is positive 2n. 12 minus negative 24 is going to be positive 36. So divide by 2, and I get n is equal to 18. Hey, same answer. So then I would just plug this in. Something minus 18 is 12, so that something would have to be 30. Don't forget, you must define the variables like I did when I solved it using the graph. So you now have 3 methods that you can solve these problems. I expect you to graph one solution and either use elimination or substitution to solve the same problem again. Good luck.